In this video, we're going to look at how to calculate the relative atomic mass, which is given the symbol AR, the relative molecular mass, which is when we're talking about molecules, which is given the symbol MR, and the relative formula mass, and this is when we're talking about ionic compounds, which is also given the symbol MR. Let's start with relative atomic masses. Now, the word relative means that you are comparing. We know that atoms are really small. And to give you an idea, a fluorine atom has a mass of 3.16 by 10 to the negative 21 grams. So it's really small. Now, because chemists have been dealing with very small items, very small things, what they've decided to do is to compare them to each other. And that's why we use the term relative, because relative means to compare. IUPAC in 1961, and IUPAC means the International Union of Pure and Applied Chemistry, decided to define a relative atomic mass as the mass of an atom compared to, that's what relative means, compared to 1/12 of carbon-12. And the carbon-12 is the isotope of carbon. So let's have a think about this. If I was to do 1/12 of 12, that comes out to 1. So in fact, we are comparing everything back to 1. There are no units because this is a comparative value. We are comparing them all to carbon-12. Now let's try an example. Now, to do an example, you need to have a periodic table. And if you don't have one, stop the video now and go get one, because you can't do this without a periodic table. So, how do you work out the relative atomic mass of aluminium? So what you do here is you go, okay, well, I've got 1/12 of carbon-12. Well, we know that 1/12 of 12 is 1. And then I go to my periodic table and I find aluminium on it. And on my periodic table, which the aluminium looks something like this, so it's 1326.98, and I take this value here and I go times 26.98. And guess what? 1/12 of 12 is 1. 1 times 26.98 is 26.98. So in fact, the relative atomic mass is always equal to the value on the periodic table. So what we're going to do now is a few examples just to see how this works. So this time it says determine the relative atomic mass of sodium. So I start by writing out what I'm doing and finding the relative atomic mass of sodium. And I know it's compared to 1/12 of carbon-12. 1/12 of 12 is 1. So find sodium on the periodic table, which is there. And sodium is equal to 22.99 on the periodic table. So voila, it's done. Let's try another example. This time we're trying to find the relative atomic mass of silver. So I go, the relative atomic mass of silver is equal to 1/12 of carbon-12. 1/12 of 12 is 1. I find silver on my periodic table. I look at the value that's here and I can see that it's equal to 107.9. This time what we're going to do is a relative molecular mass, and a molecular mass is for molecules and formula masses. Now formula masses are for ionic formula units. So this one has the symbol MR and it's used for both of them. So IUPAC has defined this as the relative molecular formula mass as the mass of a molecule formula unit relative to 1/12 of carbon 12 again. And we remember 1/12 of 12 is 1. So let's look at how to do this. So the first thing is, the most difficult thing about this entire process is writing the formula. If you can do that, you can do these. So I'm going to go the relative molecular mass of carbon dioxide is equal to the relative mass of carbon, add the relative mass of oxygen, and because the formula has 2, we times it by 2. Now we need to go to your periodic table. And what you're going to do is you're going to substitute the carbon for the actual value. And once you go to the periodic table, you can see that carbon, which is like this, 6 carbon 12.01, has a relative mass of 12.01. Add oxygen, which is 8 oxygen 16, so has a relative mass of 16 times 2. So 12.01 add 32 comes out to 44.01. Remember, there are no units because this is a comparative value. Now I'm going to do a couple of examples with you, but you do need to have a periodic table in order to do this. So this time we're going to find the relative molecular mass of water. So I know that water has a formula of H2O. So I go, well, water is going to equal the relative atomic mass of hydrogen, and because there's 2 in the formula, times 2, add the relative atomic mass of oxygen. So looking at this, hydrogen is here, tells me it's 1.008 times 2. I find oxygen on the periodic table, which is there, add 16, and this comes out to 18.016. So let's try one that's a little bit trickier than the previous one. This time we're going to find the relative formula mass of calcium nitrate. Now the hardest thing is working out the formula, which is this. And I'm going to follow my formula and substitute the values in exactly how my formula is written. So watch what I do. I'm going to go the relative atomic mass of calcium, add, there's a bracket there, so I'll put a bracket here, the relative atomic mass of nitrogen, add relative atomic mass of oxygen, times 3, close the brackets, times 2. So now I'm going to find the values on my periodic table. And I find that calcium is here, it's 40.018, add bracket nitrogen, which is here, 14.01, add brackets oxygen, which is 16 times 3, close the bracket, and times 2. Now if I follow this exactly how my formula was written, provided I can write a formula, I should always get these right. So I'm going to stick this into my calculator and I find that my value is 164.1. Let's try one a bit trickier again. This time we're going to find the relative formula mass of sodium carbonate .10H2O. This means it's a hydrated compound. So it's a bit tricky. So the relative formula mass is sodium carbonate .10H2O. Now what that means is that for every one of these there are 10 water molecules attached in. So it becomes add 10 times water. So let's get started. We're going to have to find the relative atomic mass of sodium and times it by 2. We're going to have to find the relative atomic mass of carbon, add, I'm going to have to go to the next line, the relative atomic mass of oxygen times 3, add 10 times the relative atomic mass of hydrogen times 2, add relative atomic mass of oxygen, close the brackets. That's huge. So we're going to go 22.99, remember I go to my periodic table and find it, times 2, add carbon, which is over here, 12.01, add oxygen, which is over here, 16 times 3, add 10 times hydrogen, which is here, 1.008 times 2, add oxygen, 16. And now I'm going to substitute all of that into my calculator, and I get that my answer comes out to 286.15. So as long as you can write a correct formula and use a periodic table, you should always get these right. I'd like you to go to your OneNote and try some examples. So under Chemistry Unit 2 Calculations, there's relative masses. There's about 20 to do. Make sure you get your formula correct, because once you've got your formula correct, you shouldn't have any issues.